Hello, this is Dr. R. Dilip, Department of Physics, Dr. N.G.P, Arts and Science College, Kalapati. Now today we can see about the types of aberrations. This belongs to the optics and spectroscopy. In generally optics and spectroscopy, we discuss about the properties of light like diffraction, reflection, refractions. But today we discuss about the aberrations. What is mean by aberrations? And before that, we must learn about the lens. So lens also can deviate the path of the light for converging and diverging depends on the lens. Okay, so in this video, first of all we see about lenses and what is aberrations, then type of aberrations, on axis aberration, off axis aberrations, and then few examples. Okay, first we see about lens. So we know about the lenses. There are two types of lenses, convex lens and concave lens. In convex lens, convergence of the light. Okay, if you pass the light through the lens, convex lens, it will converging at one point. That point is called as the focal point. Then the distance between lens and particular focal point is called as the focal length. Then similar as the convex lens, here the light is diverging, so it called as the concave lens. Then in generally there are six types of lenses exists. First one, double convex lens, plano convex lens, converging manuscripts, double convex lens, plano convex lens, then diverging manuscripts. Okay, let's see. Now we come upon the aberrations. So aberration in optical system, the deviation of light rays through lens causes imaging of the object to be blurred. So if you saw this first diagram, the lens is the perfect lens can converge the light at particular one point, this focal point. For in the operated lens, for example, the damaged lens can split up the points, focal the point. It's not in particular certain point, but it will diverge the so many of the point. So we can't observe the exact image of the object. So somewhat we found the blur image. So this is called as the aberrations. So the aberration is nothing but the defects on the lens is called the aberrations. So now we can see the types of aberrations. So the aberration is split up into on-axis aberration, off-axis aberration. So first we see the on-axis aberration. The spherical and chromatic aberrations belongs to the on-axis aberration, and cosmo and como and astrometric aberrations belongs to the off-axis aberrations. Yeah. So first we saw about the on-axis aberration. So spherical aberration. The spherical aberration belongs to the on-axis aberrations. So it's nothing but the spherical aberration is an optical problem that occurs. The light ray is passing through the fall on a different point of the axis, on axis. So for example, you can see here the light passes over the lens, but it can't converge at single point, but it will diverge at the so many of the point. So we can't saw the object in proper manner. It's somewhat in the blur manner only. Okay, so if you focus on, we can overcome this aberration almost 70 to 80%. So if you focus at a particular best focal point, you can overcome the 70 to 80% of these aberrations. Okay, so this green line is said to be the best focus point for to overcome the aberration, not for overcome the for all. So we can't overcome 100%, but we can overcome 60 to 70%. So this is the best focal point of the aberrations. So this is known as the spherical aberrations. So, and next one, so we talk about on-axis aberration for the chromatic aberration. So this chromatic aberration also belongs to the on-axis aberrations. So it's caused by the depends on lens index of the refraction on different colors. So you also know about the different colors have the different wavelength. Yeah. So these lens cannot focus the all colors on the same point. Okay, that's the main problem on this aberration. So previous one, the spherical aberrations, it's can't focus their particular point, but it focused multi points. But here it can't focus their same point on the different colors. So that's the important points. So here the refractive index of the lens varies with the wavelength of the color. So is the lens is failure of focus all the color at the particular point. That's the main thing. So this is known as the chromatic aberrations. So some of the example for spherical aberration and chromatic aberration. So we can see here this is the clear image of the circle, but if you saw this circle through the lens aberrated spherical aberrated lens, we can observe like this blur image. Then after that, this is the real image of this building. If you saw the by using the chromatic lens, chromatic aberrated lens, we can somewhat blurred image like this we can found. So this for the example for on axis aberration. I hope you can understood some of what about the what is on axis aberrations and how it will exhibits. Okay, then we have moved to the second part of the observations, then off axis aberrations. At first the coma aberrations is belongs to the off axis. So you know pretty well because its image is found at beyond the of axis. So it is called as the off axis aberrations. So here these coma aberrations is lens that result in the off axis point source, such as the object appear like a tail comet. Okay, so here you can see that the object, the spherical object is placed here, the same spherical object is appear at the focal point, but at the edge of the lenses is focused somewhat behind the focal point. So here the exact size will appear at then it will slowly increase the size also, and blurriness also it will increase. So the examples of comets we can see here, the images are appear like this. So tail comet like. Okay, this is called the coma aberration. Is another one, the comic aberrations also we can say this type of aberrations. So off axis aberrations and astigmatism aberration is also the off axis aberrations. So in these aberrations the object is appear like in different shape. For example, if you place a circle image, circle object in front of the astigmatic lens, means it will appear like line or elliptical shapes. So that is the called as the astigmatism aberrations. So these are the types of aberrations. At first, the non this is the original object. So here we placed as a circle, and the spherical aberrations. So in spherical aberration, the image, the object appear like some of blurriness, and in coma aberrations, the object appears as a tail comet, and aberrations, the object appear like line or ellipse shape, so it will totally change. So at summary, in this video, I hope you all know about somewhat a basic idea of types of lens and what is the aberrations. Aberration is nothing but is a defects on lens. The types of aberration we know that, and two types. One is on-axis aberration and another one is off-axis aberration, and the spherical and chromatic aberrations belongs to the on-axis, and off-axis aberrations belongs to the como and astromatism aberrations is belongs to the off-axis, and we can saw the few examples. Thank you for watching this video. Thank you.